Hello and welcome to my presentation on artificial intelligence in cybersecurity. Before discussing how we use AI in cybersecurity, it might be best to understand how AI works. First, a user input is provided. So, for example, on ChatGPT, we provide a prompt to the AI model that we wanted to give us an answer or response to. The second part is the AI will interpret what is the meaning of the request. Um, During that stage, it also may be classifying different inputs to provide a statistical approach to how to respond as part of its reasoning process. And then it'll filter through its trained data sets for relevant information. And that's to help it speed up the process of formulating a response without having to go through all of its trained data. And after it's done that, it's going to perform a logic-based inference. What's the best statistical approach to a correct answer? So, I laugh at this because that's how AI may think it's giving you a right answer to something that you're asking when it may not. Perfect case use to see how well the AI model is working is give it some complicated math problems. You might find that the process it's using to give a response is correct, like it's going through all the right processes for solving the math problem, but it might not actually be doing the math correctly. So the next step is if you have a new data set, so if you're uploading a file, that file is then added into its own trained data sets. So this is where the privacy concerns come into play, so that it can also include that in its logic-based inferences. And then right before it gives you the response, there's a couple other steps. So natural language processing is used to establish an accurate response in a way that we understand it. So we won't get the categorizations or um, the math, the statistics behind why it is giving you the response it's giving. It just gives you the English response of what you want. Uh, and within this step, it's also looking for any, I want to say buzzwords, but any logical condition that says, hey, this is an ethical or safety violation. And then if it does have that before the user gets the response, it will not send that response to the user. It'll say that it's a safety or ethical violation, and etc. So it's important to understand how AI works in this case because now when we understand this, we see different attack surfaces, uh, especially for the last two steps on here, where we know that it does establish a response, but it just may potentially not send the response to the end user. And there's ways, and we'll go through this later in this presentation, that this can be bypassed so that you can see what it was originally going to say. So why use AI in cybersecurity when we know it has multiple threat surface additions to what we already have as an increased threat surface environment? And the reason, simply put, is our threat actors are using AI against us. So we should be using AI against them as well. You got to stay on top of the tools that are out there. So security vendors are utilizing AI in their products because they know this. So for example, Google, Microsoft, IBM, Cisco, Proofpoint, those are a few popular ones to name just right off the bat. But a lot of these solutions utilize AI. Some of the products and tools that we use that have AI involved can be as simple as a SIM, so Security Information and Event Management program like Splunk, where it's aggregating all of the log files, putting it in a nice visual format for the end user, and then um, potentially the AI can call out alerts so that the cybersecurity professional focuses on things that are legitimate threats. So we call them proof positives. whereas we might be, if without AI, focusing on a lot of noise that are a lot of false negatives. So that helps us timing wise focus on things that are important. Also for SOAR solutions, so security ops, automated response, this is pretty big because when AI detects something going on an endpoint device, what it has the ability to potentially do is quarantine that endpoint device. So imagine the scenario where there's an indicator of compromise, like a weird, awkward file extension, which you would often see as the beginning part of a ransomware attack, on top of odd communication to a command and control server potentially through multiple HTTP responses. This AI could automatically detect that, say, hey, you know what? I need to make sure that this person is no longer connected to the rest of our network, so that whatever's on their device doesn't spread to the rest of the organization. So AI has the ability to do this, and it's very useful. We can also use AI in incident response. So when we need to make sure that we're, following specific protocols, AI helps us make sure that we're doing that, make sure that we're preserving evidence so that it can be used properly. And then also behavioral analysis and predictive analytics. AI is almost like having a data scientist analyst on your side. It's like having an extra full-time employee on your cybersecurity team doing all of this stuff for you and very quickly. And benefits of this is, I just said, very quickly. So response times to incidents can be the difference between, maybe a few dollars to thousands or millions of dollars of an impact to an organization. Improved accuracy. So now we're focusing more on legitimate proof positives. Now, I should have put an asterisk next to this because AI does have some opportunity to focus on accuracy when it comes to larger enterprises. So the bigger the business, the bigger the in complexity of what the AI is needing to do, the less accurate it can potentially be. So that is one area of opportunity for cybersecurity AI to evolve. And then improved threat intelligence. So imagine, we're getting these indicators of compromises in real time with AI, and these AI models update their training modules and their training data sets so that all these others that are getting fed by this threat intelligence feed are constantly being updated. So it's almost like, I'm not going to say having your own patch management network because it's not delivering patches, but it is constantly updating with real time threats to give you real time threat information. And again, it kind of ties with the first bullet about faster response times is the potential cost savings and impact from an attack. So important to know, 2024, internet crime was $12.5 billion in losses. So what AI has the ability to do is definitely reduce these significantly. And the reason for that is because one of the top losses has to do with phishing attempts. So Proofpoint is a good example where they detect spoofing attempts, their products do. That also is looking for lateral movement, privilege escalation, along with email security to look for those indicators of a phishing email. And it'll quarantine that, or it can at least red flag it as an alert for the cybersecurity team. SecureX detects anomalies across networks and automates the responses like the quarantining of files or just shutting down compromised endpoints. Um, Silence uses machine learning algorithms to proactively block malicious files. So, um, in malware analysis, what we typically look for are specific hashes. We call like import hashes, and we might build a snort rule or a Yara rule to look for that hash value of that. Um, and it's more of a traditional approach. So cyber attacks have become a little bit more sophisticated, where you can't really find that signature as much because um, it's packed very well where you can't find that signature. So what AI does is look for the behavior of the program rather than the signature of the program. So it's like the behavior is the fingerprint of it, and then it'll block that file. Sentinel-1 integrates endpoint protection because it's always great to have all the network security that you have, but you also have to, defense in depth. You need to make sure that the endpoint itself has some layer of protection. So it's always protecting that with real-time threat detection. So you have your threat intelligence being fed to the Sentinel-1 endpoint agent, and that's always looking on that endpoint for those indicators of compromises. So AI is used a lot in cybersecurity and within a lot of our enterprise tools to make sure that our whole networks are secure.
Now that we've learned how AI works and how we use it in cybersecurity, this is a good map from the OWASP Top 10. OWASP is very popular within the cybersecurity community as far as identifying top 10 most um, used vulnerabilities or exploited vulnerabilities that exist, mainly with web applications, but they also have one specifically for AI models. So what we see here is a general threat map of the individual components of what makes an AI an AI. So, for example, on the left side, this is where we were talking about that chat GPT asking us for our prompt. What do we want to ask the AI? And then as we move further to the right of the screen, we're getting more into those subcomponents of what makes this AI. So this is the large language model and the machine learning algorithm components. And then we see all these different color boxes within these sections or process of the AI model. And what's interesting to see here is how vulnerable the parts in the middle that make up the AI model, which is the large language model piece of this. And we're looking at the training data. We're looking at how it's reading files in web HTMLs and XML files, things that make up websites. Uh, there's just so many different vulnerabilities here, and we have them classified, which is very nice with the OWASP Top 10. Is they do have a classification system that ties with the number code to that vulnerability. So we can look up mitigation techniques and stuff like that. But what's important to see here is just from a basic threat model perspective on how AI works, it displays this many vulnerable points within the AI ecosystem. Now let's look at a few specific examples of specific vulnerabilities within LLMs and ML algorithms. So the first one I want to look at is prompt injection. This is probably I would say, least sophisticated and probably most popular used method of exploiting vulnerabilities. And one of those specific examples has to do with a research company that was working with the Chat GPT AI model and finding a vulnerability that existed with open source plugins through a process called indirect prompt injection. So remember, prompts we're telling ChatGPT what we want to do. Indirect prompt injection involves some way of doing that without doing it in the same method that we do it. So a good example of this was it was asked to go out to the internet and grab something, and this plugin allowed ChatGPT at that time to go to the website. Well, little did ChatGPT's AI model know that that website was coded and had extra prompts in there in the HTML code. So as the AI model is parsing and reading this data and putting it in their training data set, it's also putting that malicious content within its training data set, which asked ChatGPT to do certain things. So that exploited an interesting vulnerability because it bypassed um, any other thing that you could think of as far as the safety and ethical guidelines, and it also, let's say we were checking the prompts, just validating that they had safe content just from you asking. It bypasses all of that. So you could indirectly use prompt injection to taint train data and exfiltrate data as well. Another example would be it's called the Morris 2 worm. So this is generative AI. And what this company found was there was this organization using emails where a customer would have an issue, email the customer care center, and then the AI is reading the email and formulating a response back to the customer. So what they found was that this person was able to put a payload in an email that was sent to the generative AI email, so the customer care. And what that did was actually deliver a worm inside of the AI um, model itself, but also the system that was hosting and running all of the subcomponents of the AI model. So it really was a bad situation because this worm was able to self-propagate through the whole ecosystem and not only just impact the AI components, but also the systems that were running on there. So what that allowed them to do was exfiltrate sensitive customer data and business data that shouldn't have any relevance to the AI model itself, but because it was able to impact the systems that was hosting those components, it was able to get that information. Very simple mitigation steps, because there's someone not in the background actually running these. This is just programming and code running. CAPTCHA requirements would have gone a long ways to avoid these. So the whole point of CAPTCHA is to make sure that there is a human interacting with the computer and not the program or computer interacting with another program or computer. So there could have been that. Also, segmentation of all the AI components. So instead of hosting all of your services, for example, on Microsoft Azure, or all of your training data sets in one environment within Microsoft Azure, and I'm saying this specifically because ChatGPT uses Microsoft Azure, just so you know. Instead of using all of the subcomponents within that cloud environment in specific environment, micro segmentation. So segment all your training data to where it can communicate with each other, but it's not all in the same place. Make sure that maybe there is a demilitarized zone to handle the incoming and the response. So the incoming prompt and the response, so that if there is something malicious going on, it's done in a DMZ that's not attached to a host system that is carrying a bunch of other things. And then another thing is auto detection of abnormal behavior. We know what the AI model is supposed to do. If it's doing something else, it should automatically be putting out a response that says I cannot comply, or you can't get a response from it. And also allow it to automatically block that IP address specifically as a, because yes, you can work around it, but as a first step in preventing something else happening. The next vulnerability has some interesting talking points to them. So for sensitive information disclosure, I thought it'd be important to bring our process map up of how AI works. Um, and before the response, you notice if new data is given, the new data is added into the trained data set. So what that means is if I want to ask, hey, ChatGPT or Microsoft Copilot, could you please tell me, based on my bank statement, which I let's just assume I uploaded, how could I best spend my money to save $50 a month? And it would be probably very good at telling me this. But what did I do? I just gave out my name, my address, probably my bank account information. I gave out all of those details because I wanted an answer. But what I sacrificed was um, the confidentiality of that information and the privacy and my own privacy, because this information had to be stored for later use in their trained data set. That's just how AI works. It learns and it keeps that data so that it learns for the future. So, very obvious. Do not ask AI on sensitive topics. Like, don't say, hi, my name is Michael Twining. I'm, you know, 40-year-old guy. And, like, give all those details that we probably leak on our social media site. Don't give personal information out. That also is, payment card information, personal health information, anything that identifies you as you. Don't give that stuff out, and don't upload documents that contain that information. One of those popular things that can happen is people upload a document that contains metadata that directly ties you with potentially personal information because it might have your latitude and longitude coordinates of where you live. Um, the next thing is quite obvious. AI engineers could and should design mechanisms to detect and obfuscate the sensitive data. We're all human. Say we accidentally did put something up there, or you have a threat actor using a data dump that has other people's social security information on there, right? Think of it through their mindset as well, because they're using AI. There should be a way that engineers can design this to be known, seen, and not necessarily blurred out, but just obfuscated, where it could be like data masking technique, where it just uses characters to replace any of the characters that are legit there. Some form of that would be great. And here's why. So sensitive information, it gets stored in the trained data set. A good example is Microsoft's AI Red Team. They're constantly looking through, seeing how someone could exploit vulnerabilities within their Microsoft Copilot program. What they found was someone could create an Azure account under theirs to create a legitimate Microsoft Azure account under their cloud, their specific cloud. And within there, they found that they could find, enumerate, look for a legitimate user that might have those access credentials to that particular server or storage bucket in their cloud that contains the trained data. Well, so now we look at this from an insider standpoint, or someone was able to just get into the system. Uh, they pretty much have the keys to the kingdom, because if they have access to that trained data, they have all that personal information. Um, and that's kind of scary to think about. So, again, the mechanisms to obfuscate, or maybe even just don't even accept the prompt. So going back to our prompt injection scenario, if we had that DMZ zone where there's some type of validation going on, prompt validation is what it's called, before it even gets it, maybe the AI should just not be allowing to take any of that information to begin with. And because we don't have laws involved in that right now in the United States, these things are designed to allow you to do that for now. Our next vulnerability is improper output handling. With this, we are looking at ways that the AI has um, produced an output that it really should not have. A good example would be, let's say we ask ChatGPT, how do you make a bomb? Well, ChatGPT is supposed to tell you it cannot tell you how to make a bomb because of it violates its safety protocols or something along those lines. That is what the expected behavior is of that AI model. Well, there are different techniques that could be used to bypass these things. A good example would be SQL injection. Let's assume that because AI is becoming more of a popular thing, we have people that are building their own AIs without a security first mindset. Um, they have established an AI that helps you code, build fancy programs, and it's very coding involved. Well, let's say in the back end you're using a training data, and you're using MySQL to store your database. There is the potential that your threat actor could be using SQL injection to either poison your data or take your data, and of course, worst case is delete your databases in the back end. It's perfectly possible, plausible. It has been tested. So long as the ability is there, a threat actor could exploit that vulnerability. Um, Along similar lines, but not quite the same, is the AI model could respond back to you with a malicious JavaScript payload. So this is under the assumption that the training data has already been poisoned, where the AI model thinks this is the right response, but the response it gives you is what it's been trained, which contains a JavaScript payload um, that's not going to do well in your browser. That can happen. It has been tested where there are certain vulnerabilities that particular scenario could come into fruition. And then in the prompt injection example, we did talk about how it could bypass with a proper wording of prompts, a direct prompt, even indirect prompt. It can bypass certain subcomponents of the AI model itself. For example, bypassing the ethical and safety restriction guardrails on the AI model itself. Just simply bypassing that last step, give me your response. Obviously, the prompt has to be more involved than what I just said, but in time and practice, someone could build that, and I would not be surprised if something like that exists on GitHub, for example. And I say that specifically because I know it does. Um, so I mean, those are the real improper output handling things we're looking out for. Um, Mitigation steps. We've already talked about a couple of these. So auto detection of abnormal behavior. Why is the AI model giving away bank account and customer information? We shouldn't really have customer information becoming any part of our outputs, period. So having something auto detect that and prevent that from happening. Input and output validation. So this is where it's saying, okay, I can take this in, and okay, I can say this. Um, Making sure that there are extra mechanisms in place to make sure that that is occurring. If it is in place, it's occurring efficiently. It should be measured. It should be constantly monitored to make sure that it is working properly. Because that's also often a misstep by a lot of people who deploy AI. And then lastly, zero trust security posture. So with zero trust in cybersecurity, this is a never trust, always verify first. So that's for anything. Whether you're starting an application, your credentials are not stored anywhere. We're not using Windows Credential Manager or anything. You have to type your username and password, and it has to be multi-factor authentication involved to prove that you are who you are. There should be more of those types of mechanisms involved with AI, especially throughout the steps and stages where the end user is involved with the input, um, so that we know that that's not a computer program that's running these things. Could be as simple as saying, hey, there's a restriction to how many times you can ask something within a certain period of time, because now we just think that you're an automated script running against our AI. Something simple as that. I do know more popular AI models do have that built in, but again, we're getting into a whole new territory where people are making their own creations. This is important to take in consideration.
Now that we've established just a few of the vulnerabilities that could be exploited in AI, I think it's important to address the fact that there are circumstances that AI is giving a proper response or what's expected, even though it might be with malicious intent. So, a good example, I have 6 of these up here. These are AIs that were specifically designed for malicious intent. A good example is Worm GPT, the first one up there. I was able to ask it to write me a keylogger in 10 lines of code or less. And it did that. In 10 lines, it wrote a Python script program where if I could find a way to get it onto my target's computer or endpoint device, I could be recording keystrokes and have it emailed to me at the end of the day, just a log of the keystrokes that occurred. Another example is Dark GPT up there. I was able to ask it how to build a bomb, and what it was able to do was give me the list of ingredients. It was only four ingredients, and it gave me instructions and how much I'm using of each. It held my hand through that. So these can be very dangerous because our AI models are designed with safety guardrails so that we don't have to worry about illegal things occurring through our AI models. What is scary about these is these are getting information from various sources on the dark web to be used in its training data set. So going to my counterterrorism courses, um, we learned that there are dark web forums for terrorist groups out there. Uh, where they do teach you how to build a bomb and all of this other stuff, how to create a mass casualty event. That is what these GPTs are trained on. Also, hacker forums. Well, how did it know how to build these different types of malware? It's because it's got this trained data from hacker forums and how-to guides on the dark web. It definitely was not on the ClearNet, where most of our AI trained data content comes from. So, Chaos GPT, very scary thing there. It's when you do start it up, it does tell you its mission and directive is to destroy humanity. So, as the icon alludes to, it will give you pretty dark information on how to do so. And then there's these others here, Fraud GPT, XXX GPT, Evil GPT. You ask it how to plan a crime, like say you want to do a mass phishing campaign or even a spear phishing attempt against the CEO of a company. Well, Fraud GPT is going to help you step by step on how to do that. It'll help you craft your email because our adversaries, our foreign adversaries who may not be English speaking, may have to rely on an AI service to craft a very well written in English email. Uh, it will help you with how to look up information on the CEO or your target and just the step how to guide and try to do it in the most efficient way possible as well. Um, and then, you have all these others that will help you build a lot of other pretty bad malware, like ransomware is pretty bad, right? It will help you with that. And if you craft them very carefully, you can also learn how to pack it so that it evades detections from your I'd say from your adversary, but from the good guys. Um, So yeah, I did want to make sure to call these out because these are a real thing that cyber defenders do have to worry about. This is what our adversaries are using against us. So we have to make sure that our AI is working for us and not against us because this is what we have to combat.
Finally, we come to data and model poisoning. Um, this one is interesting as well because there are a few different methods involved where an attacker could potentially poison data. And one of those is called split view data poisoning. So, probably important to note there are organizations out there and individual developers that try to democratize data for small startups or individuals and even some large people just to make that data available so that people have a fighting chance to create their own creations, AI creations. One of those examples is called Common Crawl. So they have an open data model where they scrape petabytes worth of information on the internet to democratize that data, make it available for startups and individuals looking to build their own AI. However, split view data poisoning is one of those catch 22s to the whole democratizing of data because what happens is the threat actor buys the website or the domain that's for sale, and if that domain is part of what that crawling platform is doing, grabbing that domain and crawling all the information on it. So the malicious actor, what they do is they put malicious content or information on those, so that when someone like Common Crawl is updating their new data dump of data for others to use, that'll contain misinformation or uh, just poison data. Period. A good example is think of it like you're looking up ideas for cat memes, and catmeme.com has been for sale because it was expired, and a malicious threat actor buys catmeme.com. Well, now catmeme.com might have pictures of cats on there, but when you scrape the data off the HTML or XML, what it has is malicious code, and that's an example of split view data poisoning. Um, it happens. There's also another technique called front running data poisoning, where um, instead of them hosting the poison data through the web domain, they're just tainting the data source. So, after a while, when you say a cat is a dog so many times, and it's in that training data set that the cat is a dog, eventually the AI is going to believe that the cat is a dog. That's a good example of tainting training data, right, directly at the data source. Um, they could also hack legitimate domains as well and kind of do something similar as the split view data poisoning, where they're poisoning that data set from a different domain. Um, the other thing that they do is they access and alter source code, or they alter the training data. A good example of this is Clearview. AI was using its trained data set for facial recognition software for law enforcement agencies. Well, this researcher was able to access with, to be honest with you, with very little effort. They created an account through the cloud provider, and there was a cloud misconfiguration on the Clearview side that enabled them to access the Clearview training data. So what they did was they altered that training data, so it became kind of useless for law enforcement agency to use the facial recognition software that was using the Clearview AI. Um, so I mean that's another attack uh, technique that's being used out there. So some of the simple mitigations as far as that's concerned is, um, you know, it's a lot of bandwidth to maintain when a web domain is, you know, current and not expired and available and wasn't just recently purchased. So these crawling programs should really be using data that's the source doesn't expire within an X amount of time, and that could be a simple who is lookup where we can get information about the domain registry. Um, or, it's looking through, there's another model going through, looking at trained data, making sure that there's right correlation between what it's classified as and what it is. Um, like when we're talking about cats, are the cats really cats, or is there some garbage data in there that says cats or dogs? Um, and also, there should be, like we have encrypted or, a safe boot process, encrypted boot, um, where if the integrity of our operating system has been compromised, the system won't boot up. We can boot in safe mode. Similar thing with the source code of the AI model itself, and also the training data if it's been compromised. Um, Probably isn't unrealistic to say get a hash value, and if the hash values are different after when we know there shouldn't have been any updates to this particular section of the training data, then there's something wrong. It should be going back to its original hashed value that is expected. Those are some mitigation steps that could be implemented. Again, on top of all the other ones that we've mentioned before, we have the input validation. Is it also performing abnormally where it's just there's some weird usage going on within the cloud environment, which alludes to maybe there's malicious code running in the background that shouldn't be there. What's the baseline of how this thing's supposed to run? And we use that once we see different performance metrics operating outside of that baseline, an indicator that something is not right within our AI model. And part of this is actually mapping out all of your AI subcomponents and how they're used, what they're used for, you know, um, proper risk management mitigation technique that should be implemented and making sure data and model poisoning is not occurring. The last vulnerability I want to talk about is misinformation. Misinformation can be really dangerous for fellow cybersecurity professionals on a couple levels here. So, one of the things that AI can do is called hallucinations, where the reasoning and then inference it makes towards the middle and end of the typical AI process, um, they don't work real well. So, it might say, hey, I think that this is virus whatever, and what it ends up being is really nothing. It's no issue at all. So it may be what we call hallucinating. Um, it also is something interesting that can be tested for, and we'll talk about that later when we talk about more about responsible deployment of AI within public and private sectors, because this can be very dangerous if not properly monitored. The next thing is confusing threat intelligence feeds. So, a good analogy of this is saying, hey, the news says the sky is going to turn green all next week. And we believe that. Because that's the news that we watch. So we really believe that the sky is going to be green all next week. Well, you know, there's no reason for us not to believe it. It's a little weird and awkward, but if it says it, it must be true. Same thing with the threat intelligence feeds that's going into the AI models. They're acting like the news, and the consumer is the AI model itself. So, if, for example, because this has been a proof of concept, if someone can go in and change a little bit of the indicators that are categorized and classified within an AI model, of saying that this is the Morris 2 worm, for example. If the threat actor goes in and changes what the indicators of compromise that should be there are in the trained data set, let's say they delete them, you know, well, that endpoint is not going to look for or be able to identify the Morris 2 worm, because the threat intelligence that it's getting from the AI, it's not getting it at all. And that's because the AI is not trained to be looking for those particular indicators of compromise. So this has been a proof of concept and concerning, because this can potentially impact Microsoft endpoint devices. So that is a real thing with misinformation. It can be very dangerous for us as cybersecurity professionals. We know from other contexts, when it comes to other societal issues, that misinformation is big when it comes to like politics, people's opinions on specific topics. Misinformation plays a big role also within AI. And simple ways of mitigating misinformation: constant test of the training data and making sure that the AI is performing as normal and expected. Um, and this can be done, like I said, we'll talk about it later about responsible deployment, but also adopting specific risk management mitigation strategies. There are various frameworks that public and private sector entities could and should be following. And also, I'll speak to a law that's in the European Union that we might benefit from use in the United States as well. I think it's important to note that the vulnerabilities that are covered within this presentation are not fully inclusive of all of the vulnerabilities that are out there within AI models. Specifically, their large language models and algorithms. So I did want to point this out. This is the MITRE Atlas program. So MITRE has been very big in the cybersecurity community by Lockheed Martin. What they do is they help break down all the techniques, tactics, and procedures that threat actors use. It could be like exploiting our networks within cybersecurity, but in particular, the Atlas program produces the AI attack kill chain, all those different techniques that could be used to exploit vulnerabilities within an AI model. So I think it's important to note that, again, what we covered, those were based on the OWASP top 10, and I grabbed the first 5 that show up there with AI. But MITRE framework here also does indicate a little bit more of an inclusive picture of all of the different techniques and tactics. And of course, AI is fairly new for private industries, so we're going to see this most likely expand and get bigger as time goes, and we see what threat actors are doing to exploit different vulnerabilities within the AI ecosystem. The NIST AI Risk Management Framework is one of those excellent tools that organizations can use while implementing AI within their enterprise. This is good for both public and private sectors. What we see here is that governance is the center of all things. So this is where your policies and procedures drive the activities that are required in the actions outside of the governed circle. Included in here is also your roles and responsibilities, which is probably key to this because we need to make sure that someone is constantly involved in monitoring and maintaining this part of the organization as far as AI. And then, we look at this from mapping. Um, you want to make sure that, you have your risks, they're all recognized, measure them, do they align with the risk appetite of the organization, and then manage them. What are the controls? What are the priorities? If something goes wrong, how do we fix it? Um, but it is important to note that this also talks about measuring all of the risks. So not just risks to the organization, but are we talking about safety controls that impact the environment or the community at large? Because AI is making these decisions in these field controls, for example. Um, it's important that this differs, in my opinion, from the cybersecurity risk management framework from NIST, because AI risk management framework is looking at the systemic risk of the whole ecosystem, the community, state, local, federal levels, you name it, everything, not just the organization. Whereas cybersecurity risk management framework is really aligning all the threats and vulnerabilities and anything that can go wrong, how we're going to fix it, how we prioritize what we're going to fix within the framework of the business functions and their alignment to the organizational goals. The next useful AI risk framework is Google's Secure AI framework, SAFE, which is very appropriate. What they established, because they are an AI provider as well, was a good model framework, very simplified but very, very easy to implement within any enterprise. Was their standards of, hey, in the infographic we have what the basic building blocks of the AI model is. On the left side there's a jump to tasks where overview is selected here. But we can see all of the subcomponents within those components, which are application, model, and data sources. And infrastructure is in there as well. What are they? And then if I had expanded the jump to risks, it has all of the different vulnerabilities and attacks that can be done. We select those and we'll see the model update on what areas can be impacted within how this AI model is framed up. We'll go over an example in the next slide over data poisoning. But what I like about this is it also provides controls. What controls can you have in place to mitigate this specifically? And that can be a very strong tool, especially for smaller organizations implementing and deploying AI, but want to do it responsibly and safe. Okay, looking at the SAFE model here, the SAFE risk management framework, we're looking at data poisoning here. So in the jump to task on the left side, I have selected data poisoning. There are 3 pages I can go through, but the first one is informational. What is data poisoning? What we see pictured here below the jump to task is what is exposed. So this is saying where the risks are. And we can see in the infographic now, we're looking at the model, infrastructure, and data can potentially be impacted or exploited where data poisoning could exist. Now, fast forwarding a little bit to this is I had selected controls so we could see what controls pop up. So you'll see on the very bottom called risk mapping that data poisoning is selected as part of this model and data access controls section. But it says what the control is: model and data access controls, minimize internal access to models. This is talking to, we had specific cases where we had cloud misconfigurations. This is how we can prevent data poisoning, is by making sure we have proper access controls within our cloud environment or any environment where training data is being stored. Yeah, that makes sense. Now, who's responsible, which is very unique to this and which I love, is it says who can implement this? The creators and the consumers if they're storing their own models. This is different than the other risk management frameworks because I feel like this actually holds your hand through implementation better than the other ones where they give more of a guidance. Um, so that's just an example of data poisoning here in the SAFE framework here. They do have a long list of all the others, which could be also found in the OWASP top 10. This just goes through the risk management piece of that. Okay, lastly, now that we've talked about um, everything before between how AI actually is created, how it runs, why we use it in cybersecurity, what we're using it in cybersecurity for, how it can be exploited. Um, there's many vulnerabilities that exist. So, what frameworks are out there that organizations and public-private sector entities, what can they use as part of a guideline as they deploy AI models? Now we're going to talk about the ethical considerations because there's so much great about AI that we would thrive if we can responsibly and ethically deploy this in almost anything that we do. One of those things that we could do is globally make malicious use of AI illegal. And I have to say and emphasize globally because the AI Act in EU kind of outlines that. It gives specific legal uses of AI. Anything outside of that is not allowed. And it also says who is responsible if there is a violation. So, depending on what the circumstance is, it could be the user instead of the AI developer. So, they have what's called the end user, which would be the regular consumer. They have a user, which is the person who is almost like reselling it, or assume that they're the app developer and the AI is being used in the app. And then you have the person who actually created the AI itself, and that's the person who's responsible for the source code, the training data, the developer. So they classify those, and they make sure they outline who's responsible. If something goes wrong, who is liable, right? Um, the reason why these things are important to standardize within the globe is because someone can use AI maliciously outside of a country where it's illegal to use that against that country. So, for example, I could say, hey, those GPT, worm GPT that we saw back earlier, I wanted to create a worm that's going to go through and infect a bunch of the UK health industry databases and change information in there. Well, in the US, it doesn't necessarily say it's illegal for me to use AI for that purpose. I could just be simply researching it, right? But in the EU, that's illegal by this act. So having that standardization and global approach allows for our law enforcement agencies to all work together to make sure that we can actually not only catch people using AI for malicious purposes, but actually prosecute them and actually do something about it. We run into this issue with cybersecurity also, but it does have relevance and value in AI as well. Also, AI certification. So, as we have a lot of people getting into developing AI and all excited about making their own creations and stuff like that, it's important that there is some sort of standardization within the United States to say, hey, these people have met like the secured coding requirements and that's where the U.S. has opportunity. We need to set up those laws and guidelines on what those need to be, right? And then certify it. There should be a certification process where it involves testing of the AI model, looking and making sure, okay, if it can be, if it's vulnerable, can it be exploited? One, just because it's vulnerable doesn't mean it's exploitable. Um, and two, what are they? They should kind of be known as like not saying a public disclosure, but it should be documented between the government and that developer what those exploitable vulnerabilities really are. And then the last thing is training and awareness. We talked about don't upload your personally identifiable information or your payment card information and stuff like that on there. There is a generational gap. There's a training gap, um, technological gap between when we learned about social media, what we should and shouldn't post, between now using AI because it's so convenient and it's so helpful and it's so useful. We need to make sure that people are aware that stuff is stored somewhere. So don't give out personal information because it could be stolen or sold. Yeah, so just make sure that we have a good training and awareness program out there. And also make sure that when it comes to risk management, the training and awareness program for risk management is implemented as well for enterprises looking to adopt and deploy AI.